Sometimes asking the difference between a future method and a queuable job is an interesting job interview question to ask. I've found by being on both sides of the table in my experience that many candidates don't know the answer concretely. Let's change that now. The future method and the queuable job are, as I see it, the workhorses of asynchronous Apex on the Salesforce platform. The future method is a single method annotated with @future and takes primitives as input. It cannot receive any S-object or custom class as an input. Future methods also have to be static because they run without any initial state. In other words, you cannot have a future method as a part of a class object instance. Any state that a future method holds, it has to be built from the beginning of that method's execution, in its own context, and does so temporarily until the end of its run context. The queuable job is written as a class, implementing the queuable interface, has any number of input options available to Apex, and is chainable. Chaining means the ability to enqueue another queuable job within the queuable job run context. The same cannot be said for the future method, as it is prohibited to call a future method from within an already running future method. Each of these techniques have their own limits from within a synchronous transaction. In general, you want to be extremely cautious about firing off future methods or queuable jobs from triggers. It's certainly a practice that, while it can be useful, shouldn't be done without very careful governance or oversight in rapidly changing orgs, usually associated with mid to large size organizations. 50 invocations of future methods, as well as 50 invocations of queuables, are allowed from within a synchronous run context. Again, a future method cannot be called from another future method, and future methods cannot be called from a batch Apex context. You'll note that the advantage of the queuable job is that it can be chained. If this isn't making complete sense, make sure to review the Salesforce documentation on their full breakdown of the limits on how many asynchronous invocations can happen per context. Managing these invocations is critical to being successful with picking them as part of a solution. Mixed DML operations are another reason beyond the typical performance requirements to utilize asynchronous Apex. A mixed DML operation occurs anytime the code is attempting to modify a setup object, followed by another standard or custom object inside the same transaction. Setup object includes things like the user or the group, where the group is used in things like public groups and queues. This is very common to run into when running Apex tests, or especially developing Apex tests that perform a lot of activity on the database to set up conditions for a test. As always, check the Salesforce documentation for a full list of setup objects. Most of them you'll usually not run into issues, and you'll scarcely be manipulating them in Apex. But it turns out that user and group are very common, and that's why I've listed them here. Finally, as one last tidbit of distinction between future methods and queuable jobs, let's not forget Apex event triggers, which are their own sort of entity as well. They are entirely separate from future methods or queuable jobs. Apex event triggers are written very similarly to the way that normal triggers are, but they run asynchronously in response to the publishing of events, whether that be platform events or change data capture events. This means that in a synchronous trigger, events can be published. Then, in a separate context, those events can be responded to by the event trigger. Writing triggers for events is, again, similar to that of normal object triggers in Apex. The events are suffixed with a _e suffix instead of a _c suffix. On the other hand, when talking about change data capture, Salesforce decided they would not use a _e suffix, but instead use _change event. If you're confused why they separated them, I don't necessarily have a great answer. Maybe they just want distinct ways of identifying platform events in syntax versus change data capture events.